Okay, I'm going to talk about how to differentiate a product. So the example I'm going to use is if y equals x squared sine x. So it's a product of x squared and sine x. I'm going to give you the general formula for it. So I'm going to, general formula. 2 is going to be the example here. And 3 is going to be a proof that the formula is right. So, well, there it is. Okay, so the general formula is this. If y equals uv, so it's a product where u is u of x, and of course in our example that's going to be x squared, for example, and v equals another function of x, v of x, and that case is our sine x example. So we want to differentiate the product x squared sine x there. So how do I do that? Well, if y equals uv, then y dash equals uv dash plus u dash v. Where I'm using a dash, y dash equals dy by dx, which is the differential. I'm going to write this in a slightly different way, well, the other notation. U dv dx plus du dx times v. U dv dx plus v du dx. Sometimes you see it written like this. Sometimes you see it's u v dash plus u dash v. Well, yes. Oh, that's what I wrote down there, isn't it? Sometimes you see it written down like this. U v dash plus v u dash. Yeah, that because you've swapped over the order of u and v. It doesn't matter for these univariate functions here, but if you start to do matrix calculations, then it gets very confusing. So I'm just going to pretend I never saw it and never did that. Excuse me. All right. Well, there it is. That's the formula. Right. So let's apply it now. Y equals uv, so y dash equals uv dash plus u dash v. And in this case, u equals x squared and v equals sine x. And of course we can differentiate those two dead easy. U dash is just 2x and v dash is just cos x. So if y equals uv, which in this case equals x squared times sine x, then y dash equals uv dash plus u dash v, which equals x squared cos x plus, because that's u and that's v dash, plus u dash, which is 2x, v, which is just sine x. Well, that's nice. So y dash equals x squared cos x plus 2x sine x. So you see, it's what's happened here. If you look at this this formula here, you've got a product. This term is u on its own, and then differentiate v, and this one is differentiate the u and then leave the v on its own. So it's each one of these has been differentiated, but multiplied by the other. When it's differentiated, it's multiplied by the other one. So there it is. Now, why does it work? Why? Why is this true? Well, if I write y equals uv, then I might want to work out what delta u by delta x is. What's the differential of that? Well, I know that delta u, well, I know that u of x plus delta x equals, what does it equal? That equals u of x plus delta x times u dash plus little o of delta x. So that's a small error, which I can ignore. And of course, v of x plus delta x equals v of x, it's just the same formula, delta x v dash plus little o delta x, which I'm going to ignore. Alright, so if y equals uv, what I mean is y of x equals u of x v of x, then what's y of x plus delta x equal to? How much has y increased? Well, it's u x plus delta x plus, times v of x plus delta x equals, well, we'll just use these formulas up here. It's u of x plus delta x u dash times v of x plus delta x v dash. Okay, so when you move from x to x plus delta x, you move the right hand side to this value here. So what's delta y? Well, that's equal to y of x plus delta x minus y of x. So you ask, how much has y changed? Well, it's just this formula here. That's the delta y in there because it's just the delta y in there. So delta y equals that. So that's equal to u plus delta x times u dash, which is this bit here, times v plus delta x v dash minus uv. Because this bit here is y of x plus delta x, and that's y of x. So we just multiply it out. uv plus delta x u dash v plus u delta x v dash plus delta x u dash delta x v dash minus uv. And that cancels. This one is equal to 0. Why is that equal to 0? That's equal to 0 because it's order delta x squared, which we can ignore because it's very small, so we can forget that. And there's our formula that delta y equals delta x times u dash v plus u delta x v dash, which is equal to delta x u dash v plus u v dash, and therefore delta y divided by delta x equals u dash v plus u v dash. So the differential equals the same thing, because we're taking the limit as delta x approaches 0. Okay, I'm going to stop there.